Hello friends, welcome back to Solve for X. My name is Lungelo Gunene, and if you are watching us from Facebook, please do follow us, and if you are watching us on YouTube, please do subscribe to our YouTube channel, and the TikTok gang, please press that plus sign there. So today we are doing trigonometry. So as this is our introduction to what I believe will be one of the longest, not longest, but is it going to be long? We don't know. But today we're just going to be doing revision of trig ratios. So we're just going to be looking at the trig ratios. So, but before we start with trig ratios, we need to understand what trigonometry is. Trigonometry is the study of the relationship of sides and angles of triangles. So the word trigonometry actually means measurements of triangles. So that is what we are actually going to be focusing on under the topic of trigonometry. So now, say for instance, we have a triangle like this. And then we have theta there, right? So you will see words like opposite, right? Adjacent and hypotenuse. If my spelling is bad, forgive me. I teach maths, not English. So opposite, adjacent, hypotenuse. So now these sides, they are all in reference to theta. So, but this does not mean that you will not get an angle. I mean, maybe you can get the same triangle, and then there's theta there, and then there is alpha. So now, in relation to theta or alpha, that's when we define the sides, our sides, whether it's going to be opposite, adjacent, or hypotenuse. So then, let's forget a bit about this. Let's just explain it with this in reference to theta. So we say the opposite side, starting with opposite will be the side which is directly opposite to our theta. Then this side will be opposite, right? And then we have the adjacent. The adjacent side will be the side just next to theta, right? And there is 90 degrees. So hypotenuse will be the longest side of the triangle, or you can explain it as the side opposite to your 90 degrees. So this one will be your hypotenuse. So yes, that is how you then name your triangle. So now let's come back to the triangle. Now let's come back to the triangle that I drew here and I erased. So what if now you have a triangle like this, 90 degrees there, theta and alpha. So in this triangle, you said that side is opposite. So this side is opposite in reference to theta. But now, if you are talking about alpha, this side will no longer be opposite when you're talking about alpha, but it will be adjacent to alpha, and this side will be opposite to alpha, and then this one, because it's still the longest, doesn't change, so it will be hypotenuse. So now, therefore, the trigonometric ratio says that the sine, sine of theta will be equals to opposite over hypotenuse, and then the cos of theta will be equals to adjacent over hypotenuse, and then the tan of theta will be equals to opposite over adjacent. Right, that's it. So now we were taught this method that works to remember this. So Sokatoa. Yes, Sokatoa. You remember that sine is opposite over hypotenuse, cos adjacent over hypotenuse, and tan is opposite over adjacent. So this works. So now, understanding that trigonometry is actually the study of relationship between the sides and angles of a triangle. So now we can take the same triangle and place it in a Cartesian plane. Cartesian. Is it Cartesian or Cartesian? But yeah, in a Cartesian plane here. So a Cartesian plane actually was the idea of dividing a circle into 4 equal parts. So then it becomes the first quarter, second quarter, third quarter, and fourth quarter. So you never label your Cartesian plane as 1, 2, 3, 4, but you always start there. Why there? Because your y and your x are positive here, right? Then you come here, then here, and there. So let's say you place that one where your vertex will be at the origin. This is the origin, so then you go there, and then you come down here. So here is 90 degrees, and then here you have your theta. So you have the point there, which will be the point at the circumference of the circle. Then that point, because here it's x and there it's y values, there will be x and y. And then since any line drawn from the center to the circumference of a circle, we know that line to be radius. So we label it r. And then here it's y and there is your x. So in reference to theta then, how do we find x, y, and r? So, but we know that sine of theta equals to opposite over hypotenuse. So, right? Opposite over hypotenuse. So if this is our reference angle, the side which is opposite is y. It will be y over hypotenuse will be r, and then the cos of theta, this theta, is adjacent over hypotenuse. This is adjacent over hypotenuse equals to x over r, and then the tan of theta will be equals to opposite over adjacent, y over x. So now I am going to close this session here, but before you close this, I want you to do these questions. Pause the video. I'm going to show the questions right now. Do these questions. Pause the video to just practice these questions, and then later, before this video cuts, there will be answers just to test you on this, and then catch you next time on our next video.